Welcome, everybody. I'm really excited to have this kind of fireside chat with my very dear friend, Chris Kemp, the visionary founder of Astra Space. I heard about Astra Space in 2016 when they were still in a garage designing and building their micro rockets. Chris was formerly with NASA, and when I met him through Peter Diamandis from X Prize, I knew immediately that he and his co-founder were one of those entrepreneurs that I look for and back, people like Travis Kalanick, the founder of Uber, people like Elon Musk of SpaceX that I've been lucky to invest in. I saw in him the grit, the perseverance, and the brilliance that we look for. And in fact, they made history by being the first company, the fastest company to go from co-founding in 2016 to launching their rockets and getting a microsatellite in orbit successfully and going public on the stock exchange. So, Chris, welcome.
Yeah, it's great to be here with you, Shervin, and we wouldn't have been able to do any of that without visionary investors like you that see the opportunity and then meet folks like us and give us that capital and that encouragement to go and take the idea and turn it into a business.
Absolutely.
Yep.
Well, it's been a joy to watch you as you have grown the company and scaled the company. I remember in Alameda, you had the small office and the testing center for the rockets from a former naval base, and then continued to take over the real estate, and now you have a massive rocket factory there. Tell us a little bit about your journey and why you started Astra.
Well, it turned out back when we first met, there were a number of different companies that were building small satellites. And the idea that you could take the technology in a cell phone, the sensors, the radios, the cameras, the memory, and you could put it in space was thought to be impossible. That the satellite wouldn't last very long, the radiation would destroy the satellite. But a few pioneering companies started up and they launched effectively smartphones into space.
Right.
And they worked. And then they started to build on that and iterate. And at the time, they were really struggling because rockets are big. They're giant machines, if you've seen some of the rockets that are being built these days. And they're designed really to build people and put people in space and create multi-planetary species for humanity, not put little cell phone-sized satellites in an exact orbit. And so there were so many of these companies starting up. The real genesis of the idea was if we could democratize access to space, if we could have more launches going to more places, instead of just one rocket maybe every couple of months going to a place, we would catalyze this new industry and we would accelerate the development of all these companies.
Amazing, and you're basically talking, I remember you said this to me and it reminded me of Travis telling me that Uber was not just about taxis, it was a replacement of car ownership. And what you said to me is Astra is not just another rocket company. We're going to be the FedEx of space. We're going to do daily launches and democratize access to space. One of the areas that you've touched on as a vision from early on was this idea of an open space internet.
Yep.
And bringing that kind of connectivity to the world. And everyone has seen Starlink, but that's more of a closed network versus your vision of an open network. Can you jump into that a little bit, given what's happening in Ukraine and the use of Starlink?
Well, if you think about traditional infrastructure, if you put fiber in the ground, you've put it in the ground in your country. If you put a big billion-dollar communication satellite in space above your country, it's beaming right down to your country. But these new satellites are traveling in low Earth orbit, which means they're traversing your country in maybe 15 minutes, maybe 10 minutes. And so they spend most of their time over other countries. And the constellations that are being built by companies like SpaceX and Amazon are global constellations.
Right.
And so the big idea that we have is if emerging economies could build smaller constellations that can work together to form a constellation of constellations, much like the internet is a network of networks.
Right.
We can have a global constellation of tens of thousands of satellites providing both reliable global coverage, but also if your country wants to have the security of only routing traffic over your satellites, you can have enough of them to accomplish that use case. And so we see the internet moving into space, and then the sensors that are in space being able to bring data back across that network, maybe even have compute and storage in space, where we can just really solve all sorts of problems.
Let me just double click on this, just from an engineering mind. If you could simplify it for everyone in terms of that technical stack of imagine an AWS in space, that kind of ad hoc networking, mesh network. Could you explain to everyone in the audience how that technically works?
Yep. Well, think about a satellite. Maybe the satellite takes an image of something. Well, the satellite typically has to wait until it's over a ground station to get the data back to the cloud or to wherever it's being processed. Imagine if you could do the processing in space and figure out what you're trying to figure out. Is there water here? Is there a pipeline that's been broken there? Whatever the use case is.
Or earthquake in Turkey.
An earthquake. And what you want is you want that instantaneous. Like you want to know that that's happening when it's happening, not hours or days later.
Right.
And so what we're seeing is with more satellites and more sensors in space, the need for more real-time processing and AI being able to be leveraged so that you're not able to look at every single pixel. Humans are not looking at a picture of the entire planet every day. You need to rely on computer vision and AI to help make sense of it all and call out the things that are important.
So the actual satellites are communicating with each other in space in a mesh network with lasers, laser beams actually going back and forth between them.
Yep.
So that's technically how it works.
Yeah, it's just like if you have the internet, you have to lay a big fiber connecting this city and that city, and then in the city you have a router, and that's a physical cable. Think in space, you can just point a laser between the two satellites, and the network is actually faster because light travels faster through free space than it does through a fiber optic cable. And then you have thousands of satellites that are all connecting to each other just by pointing the lasers at each other.
So this is something that Astra Space is working on now and bringing to the world. When do you think you would be able to launch this?
Well, we've designed the satellites, and we now have the propulsion systems that are able to keep the satellites in space. And we're excited to find partners that are interested in building that infrastructure in space.
It's so exciting. If you think about it, being able to manage data in space on essentially micro servers that are microsatellites allows you to actually compute in space. Yep. And one thing that brings is you operate under space law, not terrestrial laws. That's one advantage. And you could also move the entire blockchain to space itself.
Yep. I mean, if you think about people have been climbing to the tops of mountains for millennia. Yeah. They've been putting watchtowers, they've been putting radio antennas more recently. Space is just one click higher. It's the ultimate high ground. And if you get high enough, you can travel around the world and you can be out of the jurisdiction of any country's sovereignty.
Amazing. A whole new type of sovereignty. Well, that's very exciting. In this kind of market where you have a downturn happening, this is something you and I have talked about. As I invest, as an early stage investor, I do better in a down market because there's less competition, less easy capital, the valuations are a little more sane. But we also see that the greatest entrepreneurs really rise up and show themselves most during a downturn. Yep. And I want to get your thoughts on grit, perseverance, and how you instill that culture into a company that has scaled to this point so quickly.
Well, I think it really starts with why are you doing the thing you're doing, right? If there's truly an opportunity to improve life on Earth from space, like if we think that a network, a global network that's open, that any country can participate in, is good for humanity, and your people and your investors believe in that vision that you're trying to create, a down market's great because the great ideas will always find investors and they'll always find great employees. And so to some degree, it's easier in the down markets because it weeds out all of the hype and all of the competition for talent where people are really just focused on money. If you're focused on mission versus just money, you'll be able to inspire the really talented people to come in and work really hard during the downturn.
Absolutely. Mission-oriented companies always outperform companies who are more interested in profit or other goals. This reminds me of a talk by Jeff Bezos when he was talking about the 7-year business miracle that happened when they started to work on AWS, and there was a downturn after the dot-com crash. And he said, every one of his competitors was defocused, not focused on this opportunity in cloud computing, and they were given 7 years head start. And I feel this could possibly be happening with you in this idea of AWS in space during this time, that it's harder for competitors to raise money.
I mean, we can hope. I mean, we've built a lot of the really core technologies. If you look at launch, for example, Astra is only one of 4 companies that has demonstrated the ability to put satellites in low Earth orbit that's been privately funded. You know, we have SpaceX originally, Rocket Lab, Astra, Virgin. That's it.
That's it.
And there's a bunch of people trying, and there's a bunch of people that'll get very close. But it's just like Amazon was the first. It is helpful to be early.
Right.
But it's also important that you have a purpose for what you're doing.
Right.
And I think we have those both.
Now, you and I joke, space is very hard. So rocket science in space is hard.
Yep.
But you pointed out that actually doing micro rockets and smaller rockets is even harder.
It is, yeah.
And you talked about a number of the companies that have attempted to do this. Talk about that and why that is.
Right. I mean, it truly is challenging. The last 8 small rocket launches from nation states have failed. So it is certainly not easy to build a machine that operates in the regime that a rocket does. It's traveling at its peak velocity, over 15,000 miles an hour. And when you look at the resources that it requires to just do that once, if you look at the companies that have done it, a handful of times per year, and we're in that group, but there are really no companies other than SpaceX that have done it at scale,
right,
that have actually seen, a launch a week, or a launch several times a week, or several launches within a few days.
Right.
That is, if you compare that to the airline industry, hundreds of thousands of airplanes take off and land every day at airports. How many rockets take off and land every day at spaceports? Typical days, none, right? So space is such a new domain, and there are so few companies that have mastered that domain. Even the European Space Agency and NASA have very infrequent launches when compared to SpaceX. And so really the key is to do something hard and then scale it.
Right.
So it's not just about being able to do it, it's about being able to do it every day.
Right.
And that's really hard because it requires the upfront capital to scale production, it requires quality and systems reliability engineering, and that next level of investment truly is tremendously challenging. And we're in that transom between doing it a couple times and trying to do it at scale reliably.
Absolutely. I remember Elon at the Founders Fund LP meeting where I had to present after him in 2008. That was a hard act to follow
rough,
when you're showing games on an iPhone instead of the rockets. So we were laughing about that. But he had a lot of failures that happened. In fact, multiple failures and rocket launches that failed, and the company almost collapsed. Some of the investors didn't want to fund the company, but he continued to persevere, and now look at this company. It's valued at $125 billion. I have always felt that you are the next SpaceX with a really unique thesis, and you've acted on it, and now you're calibrating between scale and consistency correctly, and be the first company to do it at scale.
We have an incredibly resilient team, and we're not giving up. We have a tremendous amount of growth. We actually started by allowing the team to go very fast, and the rockets were never going to go to orbit, right? We had, in our upper stage, we had a hunk of metal just to show the whole system come together. Now we've reached the point where we have customers that have, they're paying us to deliver things to space. So reliability is everything to us now. So just like SpaceX in the very first series of launches had, a number of failures in a row, and then they immediately focused on reliability and quality, we're in that transition state as well. And that's a difficult transition state to make.
Right.
But once you do, it's an incredible business.
Amazing. And you have a new rocket, a larger rocket that's coming. Can you tell the audience about that?
Well, what happened was the satellites started to get bigger and bigger and bigger. So we started with satellites that were maybe 1 or 2 kilograms, and then we saw them get to maybe 5 or 10 or 20, and then we saw something maybe 50, and we're able to iterate. And so as the market continued to evolve, we ultimately wanted to target a rocket that could deliver the vast majority of satellites that were out there. And so the new rocket will put about a half a ton 600 kilograms into low Earth orbit, which will address the vast majority of communication satellites that we're seeing developed right now. We can always turn that knob a little bit if we need more capacity or less capacity. But our view is you can either have the world's largest rocket and make it infinitely reusable, like a big bus. Yeah. But a lot of folks don't want to go where the bus is going or leave when the bus is leaving. They want to put their satellite exactly in a particular orbit, and that's when you need a car. And so we're developing kind of the Uber version of rockets and complementing the fantastic machines that Elon and others are building.
Love that. It makes sense. And that's which quarter of this year are you going to launch it?
But by the end of the year, we hope to launch this next rocket, and it's an incredible machine that we've built.
Very exciting. Yeah. So can you walk us through what kind of customers and what applications are they using it for, using the Astra products?
Yeah, I would divide them into two big categories. Improving the planet by connecting things. So it's your phone. You've heard Apple and T-Mobile talk about being able to send messages from your phone directly to a satellite if there's no coverage. There's broadband connectivity, like Starlink, being able to connect any place on the planet. And what's interesting is some of the most interesting places on the planet are very far away from everything. So if you're trying to figure out energy and you're trying to figure out agriculture, as we start to see AI and autonomy enter these areas, you're going to need connectivity to places where it's going to make no sense to run fiber.
Right.
And so enabling this next generation of AI and autonomy and robotics will be satellites, providing that high bandwidth connectivity that you need to train your AI and your neural networks. And I think the other area is Earth observation, just knowing what's happening. Back last year when we saw this conflict occur in Ukraine, it was actually a private company that identified the tanks coming in and crossing over bridges into Ukraine.
Oh, wow.
It was not a nation-state security apparatus. It was a couple of private companies that published these images of bridges being built and tanks coming into the country, and that's unprecedented. It's not the world's largest intelligence agencies, but it's the world's smallest and newest companies that are really pioneering this new space.
This is an interesting juncture if you think about what I always called regulatory arbitrage, where many times a company like Uber or Astra is so far ahead of the policies and laws that are written today that there is an arbitrage opportunity. We did this with Uber, with bringing in Jim Messina and Messina Group to help build their policies and regulatory strategies. How does Astra view that same opportunity and problem set, and how do you work with governments and sovereigns and states and local governments?
I think viewing space as infrastructure is the key to think about it. I mean, if you've thought about putting fiber in the ground, think about putting satellites in the sky, and there's a few things that you have to adapt in your financial model for how the thing works. But once you do that, imagine what being able to see everything happening in your country. That's what we're talking about here. Knowing where you should plant crops, knowing the performance of different seeds, and knowing where water is being directed, and having the ability to monitor your borders. You can do all this from space far less expensively than deploying a lot of capital infrastructure on the ground. So I think for nation states that see an opportunity, just like with 5G, don't put phone lines in, don't put cable in, go directly to 5G. Don't put a lot of expensive fiber infrastructure in and try to connect everything only with fiber.
Right.
Think of this as part of a hybrid architecture for your communications infrastructure.
Absolutely. And as an example of that, as we've mentioned, I don't think Putin would have ever imagined that Elon's Starlink was going to be used effectively by the Ukrainian forces in such an effective way.
It's a lot easier to knock out fiber optic fixed fortifications. I think one of my heroes said, fixed fortifications are monuments to the stupidity of man. There's nothing less fixed than a satellite traveling 20,000 miles an hour.
Right.
That's very small. I mean, this is a resilient infrastructure that can serve your country.
So the final note, so at Edison, our fund is a $200 million fund, and a big part of our thesis continues to be about space and space technologies. What do you see with Morgan Stanley saying that it's going to be a $1 trillion market by 2030.
Yep.
And currently it's 461 billion, growing at a 20% CAGR. How do you see this space in 2030 and beyond growing, and what excites you the most?
We're seeing a lot of growth. We're seeing a lot of new companies emerging that have new use cases. So the question is, how do you develop that? And the answer is, don't make them wait a year or two for a launch or access to space. So incubating space startups means providing launches. It means providing the resources that they need, the supply chain and the expertise to be successful at integrating these technologies. And if you can do that, you can leapfrog those who don't. So
I love that. Put the leap and leapfrog.
Lots of startups and lots of opportunity to catalyze the new space economy.
Awesome. Well, this has been a great conversation.
Yep.
Thank you so much.
Yeah, thank you all. Appreciate it.